Hello, welcome back to the channel where we are reviewing the principles and practices of commercial construction. This video is about chapter 16, and that is finishing. This is the final chapter of the book, so we are going to conclude the textbook review after this chapter. So finishing can be considered in two parts, exterior finishing and interior finishing. Exterior finishing can include cladding, exterior doors and windows, painting, exterior trim such as cornices, landscaping, sidewalks, and parking areas. Interior finishing includes numerous items such as partitions, wall finishes, floor finishes, stairs, ceilings, trim around the doors and windows, cabinets, and fixtures. So once the building frame has reached a point where the floor and roof are in place, or in case of multi-story buildings, several floor levels have been completed, work on the exterior walls and the interior partitions can begin. Exterior finishing can begin as soon as the structural frame has advanced to the point when cladding, exterior glazing, and painting can be applied without conflict with the construction of the frame. The amount of interior finishing done in a building will depend on the needs of the owner. In building that lease space, much of the interior may be left unfinished until a tenant specifies the amount and type of finishing required. Although most buildings require some basic interior finishing, particularly in the areas open to the public. The selection of finishes is typically done by the architect or in concert with the client during the design stage of the building. The choice of the exterior finish must be considered carefully from both practical and aesthetic point of view. When considering the performance of the material, selection is usually based on guidelines such as availability, cost, durability, insulation value, maintenance, and cost of installation. When considering aesthetic value, color, texture, and compatibility with the surrounding environment must be considered. So let's take a look at the exterior finishes and facing. Siding. Siding is the term used for the outer skin of wall assembly. Its prime purpose is to shed water as well as provide a pleasing appearance. Originally, siding was cut from wood, with cedar being the preferred choice, as cedar contains a natural preservative. More widespread softwood species such as fir, pine, or spruce can also be used. When covered with an exterior quality stain or paint, they serve very well as an exterior finish. And please take a look, there is a section showing wall cross section with siding. And also there are some of the examples of wood siding profiles, such as double clapboard siding, shiplap, plain bevel siding, V-match, um, textured rough face channel siding, V shiplap siding. Uh, Portland cement plaster or stucco. So it's commonly known as stucco, and that provides as durable, weather-resistant, and cost-effective exterior finish that can be comparable in performance to a brick finish when properly designed and installed. Colors can be added to the finish coat to ensure a uniform, non-fading finish. It can be textured and enhanced with bits of color glass or stone. And again, please refer to the textbook images. You can see exterior wall covered with building paper and welded wire lath in preparation for stucco application, and other images showing the synthetic stucco application. And also there is a section showing exterior insulation and finish system detail. Let's talk about stone and brick. Natural and polished stone exterior finishes have been used in buildings since the beginning of time. Although stone finishes are relatively costly to fabricate and install, their durability and aesthetic qualities cannot be matched. Stone can be applied to the exterior as a veneer in a variety of patterns and textures. Polished marble is a popular choice for many large stately buildings, for example. And you can see the ashlar stone exterior facing here, as well as the polished marble facing, and brick here showing the traditional exterior finish. Precast concrete. Precast concrete panels are a favorite choice of many designers, not only for their durability, but also for their variability. They can be manufactured to close tolerances in almost any shape and size. Surface finishes can vary from a polished surface to one with exposed aggregates. And here, please refer to the images. You can see lightweight precast concrete panels that can be cast in any shape, and you can see really interesting shapes here. Also, you can see lightweight trim that gives a traditional appearance to the building facade. Concrete masonry or block. Many buildings have load-bearing walls constructed of concrete masonry units or CMUs. Um, and they can also be called concrete block or just a block. Because of the durability or of masonry construction, the block units can be left exposed to the elements. Paints developed for masonry provide an inexpensive solution to the exterior appearance of a building constructed in this manner. And again, you can see images here. Entrances and exterior doors. Entrances must be designed to allow for unobstructed movement of people and yet somehow minimize the loss of heat in the winter months. In the summer, entrances must also serve as a barrier between the cool interior of the building and the outside heat. The concept of an airlock system using two sets of doors is used to control draft during cold weather and provides a transition between the outside and the inside of the building. And here you can see a double set of the doors as well as the revolving doors. Also you can see the hinge clearing details. There is a section and there is a chart showing clearance of stock size butts. Hardware, please refer to the images. They're really good and clear, and you can see, for example, installation of sealed glass unit, how that is designed and constructed. So let's move to the next subsection, that is windows. So windows provide natural light, thereby reducing the need for artificial lighting. They also provide the occupants with a view to the outside. They provide fresh air, and they take advantage of the radiant heat of the sun during winter months. Many building designs incorporate atriums and solariums enclosed with glass or acrylic panels to produce green space with the building enclosure. Again, please refer to the images. You can see glass blocks that provide good light transmission without loss of privacy. And it's a little dated, but it's still a popular design choice. You can also see a picture showing skylights and atrium in the buildings. So window manufacturers that use wood frames often apply aluminum or vinyl cladding to the exterior face of the frame to improve weather resistance and eliminate the need for paint. The interior face is primed or left unfinished to allow for painting and staining. To minimize the heat loss or heat gain through a window, a number of options have been developed. The most effective approach is to use multiple layers of glass separated by an air space, bonded together at the perimeter to produce a sealed unit. Double and triple layers of glass assembled in this manner are the most common. To further improve the thermal efficiency of windows, reflective and tinted coatings can be applied to the glass panes. In addition to the coatings, the air space between the glass panes can be filled with the inert gas such as argon. So those coatings are known as low emittance or low E coatings. And low E coatings are transparent to visible light and short wave infrared light waves and reflect long wave infrared light waves. As these coatings are microscopically thin, they do not significantly reduce the transmission of visible light. The amount of heat gain and heat loss can vary depending on the climate, allowing for a customized approach to window selection depending on the needs of the building and its location. So again, please refer to the images here. To ensure the best possible performance of a window after installation, rough openings must be within manufacturer's tolerances. If rough openings are too large, heat loss and moisture penetration may become problems. In addition, larger gaps produce greater stresses on the fasteners or anchors. Here you can see a large area of slope glazing required structural framing to support. Also, glazed domes require structural frames to support. And you can see there is a section showing thermally broken glazing for use in sloped glazing applications. So let's move to the next one, next subsection, and that is interior finishing. The main purpose of interior finishing is to provide building occupants with pleasing environment. And when we choose materials for exterior finishes, designers must consider many factors, including color, durability, soundproofing, washability, chemical stability, fire resistance, rate of flame spread, cost, and availability. So there are many factors and they depend on the project and the owner project requirements, and they can vary from state to state. So here, refer to the images. You can see drywall here with many different products available. The choices are almost limitless. However, the traditional materials and their byproducts still form the basis for most finishes. Stone, clay, cement, wood, glass, and plastics are now combined to provide beautiful, easily maintained, and long-lasting finishes. It is beyond the scope of us to cover all those finishes that are available in the stores and online these days, but in this video and actually this textbook, they try to provide some basic finishing materials, and we'll take a look at them. So let's move to the next subsection, and that is plastering. So plaster is well known and widely used for finishing walls and ceilings in many types of buildings. Either Portland cement or gypsum plaster may be used depending on the composition of the wall and the conditions to which the surface will be subjected. Portland cement plaster may be applied to concrete, masonry, and metal lath bases and is used where walls, ceilings, and partitions are subject to rough use or extreme moisture conditions. Portland cement plaster. That is made by mixing 1 part of Portland or masonry cement with 3 to 4 parts of plaster sand. Sand gradient should be different depending on the project. So the scratch coat should be approximately 3/8 of an inch thick, and it should be dashed on concrete walls unless the surface is sufficiently rough to ensure an adequate bond for a troweled coat. Gypsum plaster. Several types of gypsum plaster are manufactured. They include hard wall plaster for scratch and brown coats, cement bond plaster for base plaster to be applied to a concrete surface, and finish plasters for the finish coat over a gypsum plaster base. For the brown coat, 3 parts of dry sand are used together with 1 part of plaster. This coat is also 3-inch thick, floated, and broomed to a straight, even surface, ready for the finish coat. Let's take a look at the vermiculite finish plaster. It is used as the aggregate is made by mixing vermiculite and screened hard wall at the rate of 100 pounds of gypsum to 1 cubic foot of vermiculite finish aggregate. And this plaster is first mixed with water, and then the aggregate is added to the putty. Let's move to the next subsection, and that is wall tile. There are several kinds of wall tile that are available, and they have different sizes and different application, and they include ceramic, glass, steel, copper, and plastic tile. Accessories such as base, cap, triangles, and corners are available for most of them. Let's take a look. So here there is a typical wall tile. You can see the quarter, you can see half, you can see field, feature, triangle. Also, you can see half corners and the features, as well as the cove, base, and the cap. And there are different um, profiles here for the plastic tile as well. You can take a look at that. Also, it is shown here in the metric units for those of you who work with the metric system. So tile laying should begin at an established level and on vertical lines on the wall. If tile is to cover the entire wall from floor to ceiling, a level line should be drawn at a convenient height from the floor, measured to accommodate the base and a specified number of tiles. Then draw the top line of the tile and a plumb line down the center of the wall. Tile laying should begin at the intersection of these lines. All materials should be at room temperature between 60 and 70 degrees Fahrenheit. Apply the adhesive to the wall with a notched trowel using a wavy motion. The coating should be of sufficient thickness so that when tile is pressed against it, the ridges of adhesive will flatten and contact at least 60% of the back surface of the tile. Do not force the edges of tile tightly pressed against one another. Grouting compound made for that purpose is applied to the points after the tiles are in place. Joints are then wiped out to the desired depth, and the tile surfaces are cleaned of grout prior to the grout hardening. All right, so let's move to the hardboard section. Those panels should be conditioned before applied to the walls by allowing each to stand separately on its long edge for at least 24 hours. And they can have different face designs, such as embossed leather or wood grain, grooved, plastic coated, and plain, or cut into square like tiles. And there are so many different variations now available. So that is totally up to the designer and the owner and actually the budget. Gypsum board. Let's talk about that. That has largely replaced plaster, lath and plaster as an interior finishing material for walls and ceilings, mainly because of the ease of installation. It's commonly known as drywall construction or gypsum board or gypboard. New developments in production have led to high density gypsum board that are moisture resistant and produce excellent fire ratings. Here you can see the images. You can see gypsum board over metal studs, how that is constructed. And we are moving to the plastic laminates. Plastic laminates in thicknesses ranging from 1/16 of an inch to 1.5 inches are used in various ways for interior finishing. And edges may be butted together, but aluminum edge moldings are generally used. These moldings may be used with other types of wall paneling and plastic laminates. And again, here you can see aluminum panel moldings, you can see edging, cove, division, inside corner, and outside corner as well. Also, there is plastic laminate paneling. You can see the section, how that is constructed, and also you can see the images showing some of the finished product. Masonry finishes. Interior walls may be faced with standard brick or with brick veneer units. Standard brick may be either common or face brick, depending on the appearance that the designer wishes to create. So you can see here interior brick curtain wall, how that is designed. So if that's a load-bearing wall or interior curtain wall, that can be faced with brick, and that provide good sound insulation and a high degree of fire protection, in addition to providing a durable wall finish. Concrete masonry or block. Walls and partitions of exposed lightweight concrete blocks provide an inexpensive method of providing a durable wall finish, as well as good sound and fire ratings. So you can see there is a wall of the computer center that has been constructed with the CMUs. Also, you can see image showing wall of block units with pre-glazed finish. Uh, and you can see steel facing units for concrete block. Facing tile. Those tiles are available in thicknesses of 2 to 8 inches and may be laid with either horizontal or vertical cells. Tile laid with horizontal cells should be divided bed and head joints. So when facing tile is laid with vertical cells, the mortar bed should not carry through the wall on the connecting webs and end shells, except at corners and at ends. Ceramic mosaic. They're small flat tile units that have been assembled into sheets in the plant and held by cement on a polyethylene coated backing material or by paper sheet over the face of the tiles. Back mounted units are applied to the wall with tile cement, and face mounted usually are applied by pressing the sheets of tile into a wall coating of mortar. Stone facing. Stone used for interiors is normally applied as a veneer over walls and around columns. And thicknesses vary between 1 and 4 inches, and various face dimensions are employed. So you can see here there's a marble finish on walls and floor of lobby in large office building. And you can see the section showing stone panel wedged in place. And we are moving to ceilings, and we'll have stairs left, and that will be it for our chapter 16. So the type of ceiling to be used will depend on a number of factors, including the type of structural floor in the building, the location of the mechanical services, the intended use of the building, and whether acoustical treatment is required. Some designers will specify that for particular use, the underside of pre-stressed concrete floor slabs, such as single or double T's, ribbed slabs, or waffle slabs, may be painted and left exposed. And here you can see the waffle slab demonstrating the beautiful ceiling, and you can see suspended ceiling system with the ACT grid, as well as the mirrored ceiling and a sense of space to a room. Also, ribbed metal ceiling panels serve as grills for air distribution as well. And you can see sprayed insulation that provides acoustical treatment to exposed concrete ceiling. Acoustical tile, again, in the suspended ceiling, and many other images. So please always back up the videos with the images from our textbook. And we're moving to the final subsection of chapter 16, and that is stairs. So stairs are a necessary requirement in any building of more than one floor. Plans sometimes call for prefabricated stairs, and temporary stairs are then required until the permanent ones have been installed. These will usually be made of wood. In other cases, stairs will be roughed as construction progresses from floor to floor and are later finished as part of the interior finishing schedule. Stairs may be of wood, concrete, stone, or steel, but the same general principles apply to their planning and design. The stairway opening must be long enough to allow ample headroom under the opening header. The minimum is 80 inches. The stair must be at a slope that takes climbing as easy as possible. The angle of the line of flight should be between 25 and 35 degrees. The height of risers must be kept within reasonable limits. In many public buildings, the maximum rise is 6 inches, and in most cases, risers should not be allowed to exceed 7 inches. The tread must be wide enough to provide safe footing, and 11 inches is the minimum width that should be considered. All risers must be of uniform height and must be closed to comply with accessibility requirements. Long, straight flights of stairs without a break should be avoided. Most codes provide a maximum allowable length of stair without a landing. Stairs must be 44 inches wide when serving building more than 3 stories above grade and more than 1 story below grade, and 36 inches wide when serving buildings with 3 stories or less above grade or 1 story below grade. Non-slip threads should always be provided. Handrails must be provided at the proper height, 32 to 38 inches. Stairs with treads of varying width from one end to the other, winders, should be avoided whenever possible. Stair rails and guardrails must typically withstand lateral loading of at least 200 pounds per foot, applied at any point of 50 pounds per linear foot, whichever produces the greater effect. Wood stairs. They may be made with an open or cut out stringer or with a semi-housed, housed, or a built-up one. And here you can see the images showing that. You can see also the section. Let's move to the next one, and that's steel stairs. They can be made in several ways. One simple method is to use two structural channels back to back and weld or bolt steel threads between them. Another method of building a steel stair is when two or more structural steel members are used as stringers. They may be channels, I-beams, or heavy plate. The subthreads are hollow steel pans that will later be filled with concrete, terrazzo, or magnesite. And you can see there is a section showing the steel stair. Also, spiral stair, you can see there is a plan and the section showing that. And you can see that the threads go around the steel pipe and the handrail goes on the outer edge of the circle. Concrete stairs Reinforced concrete stairs may be precast or cast in place. Precast must be tied into the structure, which may be done by casting the top slab around the lower end. Top end of the stair usually rests on a beam ledge. And you can see some sections here showing the stairs. And you can also see the cantilevered concrete stair. And also you can see form for a closed stair, how that is designed on the wall. So when circular cast-in-place concrete stairs are designed, they present special forming problems. In the first place, the stringers must be flexible enough to be bent. Second, although the total rise of both inside and outside is the same, the total run of each varies because of the difference in radius of the circles. And the soffit must be made in sections of relatively thin material if it's to fit the warped surface of the underside of the stair. And you can see some images showing the construction of the circular stairs. And that was it for our chapter 16. Thank you so much for watching. This is the end of our review of the principles and practices of commercial construction. Thank you so much. I will see you in some other videos.